Okay, so I just wanted to kind of run through a few of the ones that you guys are going to be doing here. So 7D, let's start with. Just see, this one, this concept kind of confuses some students I've found. X plus 5 is equal to 0. And I say, okay, what's x equal to? Well, this is actually even a little bit easier than before. So we've still got two factors, right? This is a factor and that's a factor. And I just say, okay, what does x need to be here to make this whole thing equal to 0? Well, it just needs to be equal to 0. So one of my answers is just x is equal to 0. So don't overthink that one. And then this one is just like what we've done. What would x need to be there to make it equal to 0? X would be equal to negative 5. That would make it equal to 0. So just so you can kind of tell where this thing came from, though, if I multiplied x back into both of these things, this could be written as x squared plus 5x. And you could say, y is equal to, that's what that function would be. Y is equal to x squared plus 5x. And there's nothing at the end, but that would just be the same as plus 0. That's still a quadratic equation. And this thing would look like something like, you know, this. It passes through 0. I know that because that was one of my solutions, or roots we call them. So pass through 0, we go down, and then pass back up through negative 5. All right, let's do 8a. So 10n squared minus 40 is equal to 0. All right, so remember what I was saying about factoring? Always see what you can take out first. You can take a 10 out of this. You can factor a 10 out and then see what we're dealing with. So let's factor out a 10 because it's common to both. So 10, and I end up with n squared minus 4 is equal to 0. Well, I can't really do anything with that just looking at it. Well, actually, you kind of can. We don't really care about this 10 anymore. We want to know what n is equal to. And I'll say, okay, what would this need to be equal to make it equal to 0? Well, let's do that. Let's go n squared minus 4 is equal to 0. That's all the only one that really matters, right? Because we want that to be equal to 0. So if we rearrange that, this is going to be n squared is equal to positive 4. Now if I want to figure out what n is going to be equal to the square root of 4. Remember, when you take the square root of something, before we only talked about this being really like the positive value of it, right? But this is really going to be n is equal to plus or minus 2. It could be equal to both. So that's a solution. You can solve it that way. Knowing, though, you have to keep track of that. You can't just say the answer is 2. It's plus and minus 2. This thing has two solutions. So it would be a graph like this, right? And it would come down and back. Oh, that was terrible. It would go down, and that was worse. And you'd have a solution at negative 2, but you'd also have a solution at 2. So you can't just say there's only one solution there. That'd be wrong. The other way of solving this would be when you got to this point, so 10 n squared minus 4 is equal to 0, is recognizing that this is also a difference of squares. So I could rewrite this again now as 10, and then n minus 4 times n minus 2, and then times n plus 2 is equal to 0. And now I'm looking at this saying, okay, what would that need to be equal to make it equal to 0? Well, that n would be equal to 2. What would this need to be equal to? Well, n would need to be equal to negative 2. So you get the same answers. Either way, they're both correct. So however you like to do it, I'm good with that. Okay, now let's do 8e. So d squared plus 5 over 2 d plus 3 over 2. All right, is equal to 0. So now what are you going to do with this? That you're like, oh man, I don't want to deal with fractions. It's not too bad. All you need to do is multiply everything. So everything on this side and everything on this side by 2. Because if we multiply everything by 2, so let's say we multiply the left side here by 2, well, that would become 2d. And then really we're saying this is multiplied by 2 as well, and so is that, right? So they end up just canceling with each other, and we get rid of those fractions right away. So that's kind of the whole point of why we multiply by 2. So that's kind of a little trick here, right? So now if I, oh, and then the other thing to think about here, though, is that if I multiply the right side by 2, if I multiply 0 by 2, didn't change anything. But we're allowed to do it. You can do whatever you want with these equations as long as you do the same to the other side. So we can rewrite what we have on the left side now. We have just 2d squared, right? 2 times d was that. 2 times that is going to be just 5d, because when we multiplied it, that would have been 2 times 5 over 2, but the 2's canceled. So it's just 5d now. Plus, oh, that went away, just 3 is equal to, this is still 0. So now we need to factor this. So we're looking for numbers that multiply to 6 and add to 5. So I'd say 3 and 2. Yeah, positive 3, positive 2. Good to go. So let's rewrite this again. 2d squared plus 3d plus 2d plus 3 is equal to 0. Let's factor this part on its own. So we can take just a d out of there. We're left with 2d plus 3. If we factor this one, we can't. We've just still got plus 1. And then 2d plus 3 is equal to 0. So our factors here would be 2d plus 3 times d plus 1 is equal to 0. Now I can look at this and say, okay, what would d need to be? Well, let's make another little mini equation here. So I'd say 2d plus 3 is equal to 0. Now if you rearrange this, subtract 3, d, and I'll do the whole thing. 2d is equal to negative 3, and then divide both sides by 2. d is equal to negative 3 over 2. So that's one of them. The other one, this one here, you can just kind of see from looking at it. You could do it that way too, but you could also say, okay, d is just equal to negative 1. Probably do that one in your head. So those are our two answers, that one and that one. All right, that's going to be it for that video. Hopefully this is going okay for you guys.